Welcome to screencast session on week 3 quicksort. So we are implementing here two functions. First we are implementing the partition function. The partition function takes that list and as well as that lower index position and upper index position. The job of the partition function is simple, placing the pivot element in its right location and return that particular pivot element location. We are doing that initial setup for this. We are getting the pivot, that is that list of the lower, which is the first element of the list we are fixing as a pivot initially before we are picking out. So then it is lower, we are initializing into the I, and we are implementing the two cases. The first case is increment the j. So whenever you found that all the cases, like the j is always it is incremented, so that what happens, so for j is incremented in a range of, so lower index position plus 1 to upper index position plus 1. So that upper index position plus 1 means it goes up to the upper only. So the j is incremented every time because of the iteration, simple iteration. But I is increased if and only the list of j is less than or equal to the pivot. So the condition what it stands for is, we are incrementing the I if and only the smaller element or equal element than a pivot is found. So every time we are increasing that I equal to I plus 1. So then we try to swap it, so that once you swap it, bringing all the elements of the particular pivot, so is left side elements are smaller, right side elements are bigger. So we want to do that. So for that there is a swap is required between that list of I and list of j. We are doing that swapping between the list of I and list of j. So this is a continuous swap every time whenever that smaller element than pivot is found. So once you have done it, so then finally we try to swap. So this could be the second case. Actually this is the second case we have implemented. So after this complete iteration, what happens, we got that. So the final index position of the pivot into the I. So let's swap it, so that list of lower, and we are swapping with, so list of I. So where the I is the right index position of the pivot. So that is list of I and list of lower. So what does it mean, place the pivot in its right position, So this right position we return it, so that is just I. So we got it. So finally what is this I is? So pivot index position. So wherever it is placed in its right position, so that bringing all that left side elements are less than or equal to the pivot, right side elements are greater than the pivot. So now do that, the recursion calls. The recursion calls we do with another function, that is quicksort. It takes that lower index position and upper index position as a parameter, but it's a recursion calls it will do. So initially whenever this recursion calls of general case 1 and general case 2 you want to call it, say if and only that lower doesn't cross over that upper value, so that always upper index value must be greater than that lower index position. In this we try to do the two recursion calls, but before calling the recursion calls I should know what is my first pivot. So first pivot I am getting, so that pivot position we are getting through a predefined function which is there, partitioning job. So this partitioning job, what it will do is initial list and what is its first pivot, and that pivot in its right position it will return. So once we got it, so then we try to do that recursion calls. The recursion calls, what it will do, again we try to do the same job on the left partition, same job in the right partition. So let's do that. Quicksort function we are calling. We are doing that lower, but upper index position is somewhat interesting, that is pivot minus 1, so that it will concentrate on the left partition. So again we do the quicksort function, but we try to do the quicksort process again on the right partition. So we do that is pivot position plus 1, because pivot is already placed in its right position. Again investigate the next pivot in the right partition. So that is up to the upper. So and after all that, if this particular if condition is not satisfied, so this if condition is not satisfied means we reach to the base case. The base case is simple, we got that complete sorted list and we return that the list. So hopefully we have done everything with the right indentation. So now you write that main function, the main function I am defining with constant list of elements. So that is that 78, 2, 5 and then 2 and then 1, and then it is 7. So this list I want to call it through that quicksort function, where it is repeatedly doing the recursion job, finding partition and making its right position so that all pivots are done so far. So that list is going to be sorted. My list is this. My list of elements is 0th index position 2. So 5th index position, because we have 6 elements, we got that lower index is 0, upper index is 5. So now let's run this. So we got the sorter list so far, that is, so 1, 2, 2, 5, 7, 78. So thank you very much. Have a nice day.